Hello, my name is Martin Roux. I'm a cinematographer. I'm one of the creators of Diachromie and Diaphanie, distributed by HAL Picture. And in this video, we're going to do a little look development, crafting a look in response to a very common request. Produce a look that imitates Kodak Vision3, that means 5219 shots on 2383 print film. That's a typical contemporary film look, and that's something that we often need as a DOP. So to do this, we have two types of images. Images shot on film, a gray gradation, and a complex shot with a lot of color information. And we have the same shots shot in Venice and color managed in ACs, as you can see right here. Diachromie and Diaphanie will be used to produce a color behavior in ACs that mimics the color rendering and the contrast of the Vision3 aesthetic. And you'll see it's both surprisingly simple and fast. Diachromie and Diaphanie allow us to draw a contrast curve, color tone curve, and color volume modifications. We will therefore reproduce step by step the color behavior that we can observe in the Kodak Emulation. So we are going to put a Diachromie instance on a node, just right here. And let's look at the gray gradation shot in Venice. All we need to do is display the same gray gradation shot on a film in a wipe. And what we can see on the waveform is the offset between the two curves. That's to say, the contrast offset between the normal AC's rendering and the 5219. So we're going to use Diachromie and match these two contrast curves. So first of all, there's a lack of contrast on my Venice shot. So I'm going to add a little bit of contrast. And then let's fix the black level. Let's fix the black level, which is quite easy because I can see the black level very well with that line. And then the shape of the curved toe. And then we can go back and forth like this until we are very happy with that. And you can see that with very little effort and few clicks, we've produced a contrast curve that matches the 5219 perfectly in terms of contrast. So I'm bypassing the curve, and you can see the two contrast curves are now precisely the same. The next step is to reproduce the color casts that we see on the 5219. So to do that, we are going to display the color targets of Diachromie just right here. I'm just putting the waveform in RGB so I can see it better. We need blue in the low light. So it's very easy to choose the hue and then to add saturation. So you can see that the low lights are turning blue. It's fairly pronounced blue. And then we need orange-red in the highlights. At the same time, we need a little less coloring in the very highlights. It's a roll-off offset setting. Then a tiny bit of green in the middle of the curve to neutralize the middle of the curve a little. And once again, you can see that in just a few clicks, with Diachromie tools, we have matched the contrast curve and the color behavior we observe in that film sample. So let's watch the curve we've produced. I can display the curve just right here. That's it for these charts, and that's it for the 1D transformations. And now let's move to the other charts to adjust like the color behaviors on the volume. So the aim here will be to match the color behavior of that chart with the charts filmed in film. So I'm going to wipe the other chart, just like that. you can see there are huge differences, but the idea will be to copy the color behavior of the 5219 onto the charts on the Venice 2 shots using the 3D transformation tools in Diachromie. You can see that this is where the complexity of reproducing a color rendering lies. First of all, we want to change the hue of the colors, but also the way the saturation gradations evolves. So the yellow is both much more orange, but also it evolves towards a denser color. The green is much colder and also much denser. The blue is less saturated and less bright, and so on. So let's start by importing the contrast setting we've just developed, just here on the other chart. And you can already see that this contrast setting produced an interesting effect on the Venice shots. Now we need to do the same with color. The first thing we can do is to match the hues. The red needs to be a little bit more orange. So I'm turning the red to orange. Then the yellow needs to be a little bit more orange too. All right. The green needs to be more blue. All right. Let's leave the cyan where it is for now. And then the blue needs to be a little bit more cyan. And the magenta needs to be more blue. All right. It's just a first step, but already you can see that bypassing diachromie, the color charts has changed appearance. The next step is to compress the saturations and brightness of each of these colors to make them behave as desired. As it is often the case, it is by playing with several sliders in relation to each other that we will change the color behavior color by color. So to get that color behavior on the red vertex, I'm going to play with saturation control along with the color density control, which allows to reduce the density of the more saturated colors. So by enhancing the low saturation with the color boost and decreasing both the saturation and the density of the most saturated red, I'll get that film rendition of the high saturation. And you can see that with just one click, or two clicks, the saturation curves start to look very similar to what we see on the chart shot with the 5219. Look at that, I'm just bypassing. The Venice shot is changing completely in terms of how the red saturation evolves. So same thing for the yellow. So decreasing the brightness, enhancing the color density. We are also going to add a little bit of low saturation to increase the saturation on the darker parts. This is quite important for the red and the yellow, where the skin tones are. During this operation, it is perfectly acceptable to tweak the hue or any other parameter that you realize isn't quite right. And we'll continue like this, color by color, until we achieve a perfect match. Going back and forth between colors is perfectly acceptable. It's a slow process, so you need to be patient. But working meticulously, you can get there. This rather large number of operations deserves a quick fast forward to get to the result. Sorry for that, but as you can see, there's a lot of stuff to do. I'm going back and forth. It's not like just adjusting one time and it's done. You have to check several times. And of course, when you change the color a little bit, the adjacent color can evolve also. After working hard to align the color patches, we have quite a satisfactory result. If you look at the behavior of the color charts, it has come considerably closer to the behavior of the 5219. That said, we can say that the faces and the skin tones are not entirely satisfactory. In fact, in trying to match the most saturated colors, we may have neglected the skin colors a little. This is not a big deal because Diachromie offers dedicated sliders for skin color. Often a very precise color target on saturated colors can take us to undesirable place in terms of skin color. It's important to be able to adjust this separately. We want warmer and lighter skin tones, and we want also more saturation. And most importantly, we're interested in the redness of the skin because we want the lips to be more orange, but also much more saturated and with the right density. We're missing an important step. We're going to add a little bit of texture to it because a little texture will help us to fully appreciate our look. So I'm going to put a Diaphanie node and I'm going to set Diaphanie to the 35mm setting. And there we are. Here's the image of the Venice, and here is my Vision3 look. And if I bypass the look I've put on the Venice, you can see how huge the transformation is. Let me reassure you right away, you don't need to do that by yourself, because Diachromie integrates a Vision3 look built in. It's such a common request that we have crafting a look that is available for you all. You can keep this Vision3 as it is or make it use by slightly shifting the tones and adapting it to your project. That's the power of parametric tool, the ability to adapt any of these looks to your taste. Leave the classic Vision3 representation behind and create your own interpretation of what a Kodak look should be. We will now take this look and apply it to a timeline of completely different images, which will allow us to appreciate the robustness of this look on different images. We find the same color shift, sometimes very strong, but always entirely appropriate and very pleasant to watch. The same synergy we know from Kodak with slightly orangey skin tones, very high saturation that tends to compress and become much softer. The vegetation is also less present, but in a very pleasant tones. And above all, as you can see, there's very beautiful neutrality. Many Kodak plugins or presets give a very warm or green, but definitely not neutral interpretation of what a Kodak should be. A Kodak film, if it's properly exposed and processed, can be totally neutral, at least on the mid-gray, as you can saw just earlier. Otherwise, how color film could have been made for so long? So it's important when trying to make a Kodak emulsion to be able to start from a neutral base. On the other hand, you are of course free to add a little bit of color cast or to tint it or to change its appearance if you feel the need to do so. That's all for that emulation of the Vision3 look. As you've seen, it's not that complicated if you have the right data and the proper tools. It's totally doable. That's all for now. Thanks for watching and see you for the next video.